Hello. Hello, everyone. Good evening. Am I audible?
Yeah, audible.
Yes, Abhishek.
Abhishek, good
How are
evening.
you?
Good evening. Good evening. Good, good. Very good. So let's start with this NumPy. I hope almost everyone has attended one or two class of NumPy, right? NumPy has started, or few people might have finished it, right? How it is going? So we are. This is just a kind of revision session. We are going to learn about the uh, yeah NumPy in detail. So probably it might take some extra days. So like around 3 weeks or 4 weeks it will take. So let's see like how we'll continue. Classes will be on Monday and Wednesday and Friday, and it will be from 7:30 to 9 or 9:15. I will continue. So I have a call after 9, so probably I may drop after 9. So we'll make it from 7:30 to 9 or 9:15. We'll see. Okay. Um, Apart from that, recordings will be shared in YouTube, so you can go there and you can check. So let's start. So first question is, what is NumPy and Pandas, and why do we need that? Okay. So understanding NumPy and Panda, like see, NumPy and Panda is just a module, as we all know, and they are used for mathematical calculations. Why, why NumPy and Panda? So see, basically, NumPy and Pandas are the techniques for loading, storing, or manipulating the memory data in Python effectively. So basically, let's say if I will say Python has its built-in array module. Okay, there is a array module in Python, and this module you can use to create an array. Now the question is, why do we need array then? Why can't we do our why can't we do with list, or why can't we do with tuple? Why do we need array? So see, basically list is not the efficient storage of the data. Okay, like if you want to store the data in list and array, so the amount of memory that will be taken by list will be comparatively higher, and also you cannot do a lot of operations which you want, which arrays allowed you to do. We will see all those operations, what all kinds of operations are there which makes our life easier compared to list. Okay, so we will be looking at all those methods. But why do we need NumPy? So basically NumPy and Panda, they give you the effective techniques to load, store, and manipulate the data in Python. Okay. Now, the question is, why only array? So array, basically, if you will talk about the data, right? Whatever data set you get to process, these all data sets you can represent in form of array. Okay. For example, if I will talk about images, it can be represented in array. If you will talk about textual data, that can also be represented in the form of array. Okay. If I will talk about audio clips, this also can be represented in the form of array. Okay. Or apart from this, there are different kind of data. So documents we get, so those all also can be represented in the form of array, or numerical measurements, anything else, whatever data you are getting around us. Or like see, probably you can say the data I'll be getting from retail or banking or any other domain. So whatever data you are getting, those all data can be represented in the form of array. So that's why learning array and doing the processes or doing the operations on array becomes important. Okay. uh, so you can say that, let's say if I'm defining an array of numbers, for example, this is a two-dimensional array of numbers. This is 1 2 3, and this is 4 5 6. It looks like list. So I can do this operation, whatever I want to do, I can do. I can keep this array in the form of list also. So as I told you earlier, that list doesn't provide you the efficient storage. Okay, this is one of the reason we cannot go with the list. Another reason is the efficient manipulation of the list is also not possible. For example, if I want to multiply 2 with all the elements in this, what I need to do, I need to run the loop. Okay, whereas if you will define it as an array, okay, if you will define this as an array and if you will multiply it with 2, so this 2 will get multiplied with all the element. Okay, so for this, like, apart from this, there are a lot of operations which we'll be having a look in upcoming classes. So what all operations are there which are not possible when you are working on the list? So list is probably, you can say, ruled out of the option. And we will also see that how list is internally stored and how array is getting stored. Probably that will give you a fair idea why do we need Numpy and Pandas, which are built on top of the doing the manipulations on array compared to the list. Okay. Okay. So one thing we have understood from here. One thing we have understood from here, that data set. So we need to understand data set is that data set is nothing but the collection of most of the data sets, whatever you are working upon. They can be represented in the form of array, whether it is document, image, sound clips, or textual data, anything that it can be represented in the form of array. If you, those who are from technical side, they may remember if they have done the image processing. Okay, so image in form of array, if you will see this, so probably somewhere you will find it is not showing here.
Abhishek, are you trying to show us apart from anything from the Jupyter
Sorry, you
notebook?
are saying something.
Apart from the Jupyter notebook, you are showing
Your
something?
voice is not audible.
Am I audible?
Yeah.
What I'm saying is, like, we are able to see Jupyter notebook only. Are you trying to show us something else?
Oh, okay. So it's not showing here. I found one link I was looking for. I forgot that what exactly. Yes, this is. Yeah, so. Not showing. I forgot the keyword with what I found one image. I forgot that keyword with what keyword I searched. But you can do the search with the different keyword. What you will find that there is an image and it can be represented in the form of array, a two-dimensional array with respect to the brightness and contrast which you have in your image. Okay. So any image basically can be represented in the form of array. That's what I wanted to show anyway. So basically one thing we have understood, that data set is nothing but any data set you can represent in the form of array, whether it is image or textual data or audio clips, whatever data you are working upon, that can be represented in the form of array. So now data science means what? We are going to do the operations with the data. So if you want to become a good data scientist, then you need to have a good hold on array operations and array related tasks. So that's the reason we are main focusing on Numpy and Pandas. That is the important aspect here of our these classes. So the next part is what the next question is, why do we need Numpy and Pandas when we already have list in Python? So yes, we have the list in Python, but the most useful and simple calculation that you can do in array or on array using NumPy and Panda, that is not allowed in list, that we have already discussed. And when the data grows, then the efficient storage of the data becomes an important aspect. If you are not going to store the data efficiently, probably it will take a lot of memory, and then your system will not work properly. Whereas when you use NumPy and Pandas array in NumPy and Panda, so it stores the data in the form of array efficiently, and it will take probably the less amount of storage compared to the list. Okay, why it takes the less amount of storage? So for that we need to understand that how a list is stored in Python. Okay, before that, let's say if I will talk about integer value. If you remember in our discussion in the normal classes, so let's say if I'm writing a is equal to 10. Okay, so here I am not specifying that it is an int value, but still it is taken as an int value. Okay, and if you also remember, I told you that there is something called reference count. Okay, there is something called reference count. As soon as this reference count reaches to 0, this object will be deleted from the memory. Okay, and if you have at least 1 or 2 reference count existing, then that particular object will be there in your memory. So how this data is getting stored? So any integer data or any data which you are storing in in Python, so it not only the data, apart from the data, few more things are getting stored. So in C, when you write a is equal to 10, int a is equal to 10, so that int a is equal to 10 is just a number. Okay, that number is getting saved in the memory. But in Python, along with that data, along with that digit 10, other value which are getting stored in Python is object reference count, object type, and object size. Okay, if you will have a look at the size of int in C. So this is somewhere 1 byte, 1 byte, 2 or 4 byte. Unsigned int is 2 or 4 bytes. So you can check it is not going to be more than 10 bytes, or let's see this table. So 2 bytes, 8 bytes. It is maximum 8 byte. Long and unsigned long are also getting stored in maximum 8 byte. But if you will come here, let's say if I will talk about this, int a is equal to 10. So import sys and print sys dot get size of a. So it is 28 bytes. This is byte. Okay, it doesn't gives you the unit, but this is 28 bytes. Why it is taking 28 bytes, only 10? Whereas if you will store this same 10 in C, so maximum it can take, if you will assign, like if you will declare a variable as long type, it will take 8 bytes only. But in Python, it takes 28 bytes. Okay, so why it is taking 28 bytes? Because whenever you declare any data or any number, so or any kind of data, so internally the things which are getting saved in memory apart from the data is, it is object type. Okay, it is the reference count. Okay, and apart from this, the digit itself will get stored, and also object size. Okay, object size and the digit. Okay, so this is the 4 things which will get stored and which is related with this particular data 10. Okay, this all 4 things are stored in the memory, so that's why it takes the larger amount of memory, which is 28. Okay, whereas in C it's just a number. So for example, if I will draw a image for this, so let's say if I'm talking about C integer type, if I will write a is equal to int a is equal to 10 in C, if I'm writing a is equal to 10, a is equal to 10. So in C, there will be, let's say, a consecutive block of memories, and in some memory, the 10 will be stored. Okay, let's say 10 is stored here. So basically, A is pointing to this in case of C. Okay, in this memory location, or the name of this memory location is A. That's how when you use printf A, so it prints this value. Now, when you come to Python, okay, and in Python, if you write a is equal to 10, a is equal to 10, so how this 10 is stored in Python? So this 10 is stored in Python. There will be a memory block which will be taken, let's say 28 bytes, so 28 byte of memory block will be taken, and this 28 byte of memory, first it will have one something called Python head. Okay, and this Python head will store the extra information related to this. For example, the thing which I said, object underscore type, comma, object underscore size, and reference count. Okay, these 3 things will be stored here. And apart from this, the 10 digit which you have written, that will also be stored here in this. Okay, this is the 10 digit. Okay, which is stored in this. Now this whole memory block, which you can see, this bigger one, this is the size of the integer value in Python. So obviously you have larger, or larger set of values to store, so it will take larger amount of memory, right? It will take larger amount of memory. Okay, so that's how it is created, and that's how the integer behaves. Now if you have understood integer, so let's see how Python list and Python arrays are stored in Python. Okay, so let's say list versus array. Now I'll say list versus array. So how they are stored in Python. So we can see one thing, that how integer is getting stored. So if you want to store just one integer, this is the whole value. Now we need to understand what is an array. So array is a kind of list, but it is the homogeneous collection of the data. Means it can take only one type of data. For example, it can store only integer, or it can store only object. Let's say you can say string, or it can store only float value. Okay, so or any a single type of data. So I can say array is a special case of list, right? Array is a special case of list. So when I'm saying array is a special case of list, means array is a list, but it is storing only a only a special kind of data. For example, if one data, if it is int array, so it will have only integer values inside that array. If it is a float array, then it will be having only float value inside that array. Okay, no, I'm just explaining, so I'm not writing anything right now. Correct. So I hope you are able to see this. I'll be explaining it here, so don't worry. Okay, so I can say that array is a special kind of list. Okay, so whenever I'm saying, let's say if I have a collection of 10 numbers, 1 to 10, okay, as a list. So if I'm storing it as a list, then all the 10 numbers which I have created, okay, all the 10 numbers in the case of list will be pointing to this object. So every number will be having this in the case of list, whereas in array, how it is represented, so there is a, okay, so let me, So let's say if I'm saying an array in Python, so that array in Python looks like this. Now, this Py object head will be storing, let's say this is, if this is an array, Python array. So this whole array is a sequence of numbers. So this will be having, let's say 1, 2, 3, dot, all these 10 numbers it is having, correct? So all these 10 numbers, this consecutive blocks of memories are having. So these blocks of memory will be represented by this data, and related to these blocks of memory, the type, okay, object type is array, then object size, how much size it is taking, and then object reference count, how many references you have created. For this array, it will be stored in Py object head. Apart from that, the extra information related to dimension and strides, that will be stored in some other location in the same this Python. This whole is representing Python array object. Okay, so these all informations are stored. Now if you will see here, all these numbers are stored in a consecutive block of memory, and since it is only integer type, okay, so I can store it in this way, and only one reference will be created from the data. Okay, now let's see if the same array numbers or consecutive value of numbers, if I will store in the case of list, then what will happen. So in the case of list, so this is going to be Py object head again, Python object head, and this is going to be the data. Okay, now this data will point to this array of numbers. These arrays are nothing but again sequence of IDs. Let's say I can say ID1, then ID2, okay, then I can say ID3, and so on till ID10. Okay, so all these values, see, internally we have seen that in the case of string or in the case of list, the values are not stored at some location. So values, individual objects are stored in the heap area. Okay, and in the heap area, this list index point to that particular index, correct? So if I'll get the id, let's say if I have a list, this is a list 1 2 3 4. So 1 2 3 4 are stored individually in the heap area, and this list of 0 will point to that one, then list of 1 will point to 2, list of 2 will point to 3, and so on, correct? So the same concept you can see here. Id, actually this data which is pointing to this array of number, it is not the numbers, they are a reference to the IDs. What is the ID? Where these data or numbers are stored, whatever number you have taken in this consecutive block of memory. So it is taking more amount of memory, right? It is first storing at the individual level, then it is creating an array of IDs, and then that is referred by this data. So obviously in the case of list, it is going to take more and more memory if your data grows, and it will not be efficient to store the data in this manner, correct? Whereas when it comes to Python array, so you can see that since all the numbers, we know that all the numbers are of similar type, so here all the numbers can be stored in the consecutive blocks of memory, and then that will be represented by data. In the heap itself, that array will be created, this whole array will be created, these values will not be created individually. Okay, this whole array will be created, and then this data will be pointing to that array object. Clear? Whereas in list, see, in list you can have heterogeneous data type, right? You don't know, let's say this is integer, this is a list, it can be, the third can be a float, fourth can be a string. So you don't know, so you cannot create a array structure like this in the case of list. Okay, it will not allow you to do that, but in array you can do that. Is this clear, everyone? Okay, styles is the extra information related to the array, so those we will discuss whenever it is required. But see, apart from array, apart from these data, there are a lot of information are going to be stored related to the array, that will be stored in this. Okay, fine. Any question? Yeah, it can have multiple array, so that will also be multiple array means to say it will have multi-dimensional array, right? So it will have two-dimensional or three-dimensional array, so accordingly it will be created. That is a different concept. Okay, but if you will see at a simple array, so it is getting stored here. Now when it comes to multi-dimensional array, we will also see that how multi-dimensional arrays are stored. But if you can see at the very granular level how this list, simple list and simple array are getting stored. So if simple array is memory efficient, then multi-dimensional array or higher level of array will also be memory efficient. Okay. Okay, Sankar?
Yeah, okay.
Okay. Now, so now we have seen that how we can store this array in Python. So having discussed this, let's say, any question here from anyone?
So the array is also having the homogeneous value?
Array is the collection of homogeneous value only.
Okay.
Array cannot have heterogeneous values. If heterogeneous value comes, then it becomes a list.
So, Abhishek, just one question. So, when we tell that everything can be stored in an array, right? But it has to be homogeneous. So, how come the conversion happens from, let's say, images or something else? When we store, how does it get converted to integer? It's based on the ASCII or something?
No, yes, internally see, if you are writing anything, whatever you are, we have discussed in the very first class that whatever
The ASCII,
even this
yeah.
Google Chrome is also a kind of internally every instruction is getting converted into binary signals.
Right,
Everything
yes,
is
yes,
binary.
yes. I remember that. Okay.
So even images internally also, if you remember, I told you they are getting stored in the form of bytes and byte arrays.
Okay,
So
okay,
that
okay.
bytes and
Okay.
byte arrays are also.
Got it, Abhishek. Thanks. Yeah. Sorry.
Okay, so now you have seen that how important the array is and array discussion is. and how important to learn about array. So if everything is an array, then learning array is the most important part, and that's what we are going to do. And this also array related operations basically will be learning in Numpy and Panda. So one thing is clear, that we can keep the list apart for different operation. List can be treated in a different situation, list can be useful in a different situation, but when it comes to data related operation, list may not be the ideal. Okay, list may not be the ideal case to consider. Okay, so we have to consider array only. Still, is it breaking? My voice is breaking for everyone. Okay.
No, it's fine.
Okay, Neha, please check from your side once. Okay. So array has to be, you should have a good hands-on on array. So that's why we have developed a different module at all, like NumPy. First we came up with NumPy. Now on top of NumPy, we came up with Pandas. So Pandas is basically the advanced version of NumPy, where you can represent multi-dimensional data and you can just label arrays, rows and columns. Okay. So NumPy is also used to store the data. Okay. So NumPy basically provides you the efficient storage of array. Okay. So NumPy is for that. But when it comes to efficient operations, probably again NumPy is lagging somewhere. So we came up with efficient storage and efficient operation. That is the Panda model. Okay. So we'll be looking at all these examples. Let's move ahead. Now, what I'm going to do, we will create few arrays. So any question till here? Anyone having any question? Okay. So now let's move to how we can create an array then. So we have seen that why NumPy is required, why Panda is required, why array is required. So all this discussion we are done. Now we are going to do some hands-on. So we'll see how we can create an array in Python using NumPy. So first of all, if you are going to create an array using NumPy, so you need to import NumPy. Okay. So if you are going to import NumPy, so you know that how you can import. You simply need to write import NumPy, and it will import the module. The most used acronym for NumPy is NP. Okay. So in most of the cases, wherever we use, like for example, if you remember, I imported, okay, a name to this math module as M, and if I want to use any function defined in this, I should not write math.sqrt of 4. It will give me the error. Math is not defined. Whereas if I want to use this, so since I have renamed it as M, so I will give it as M. Okay, so now it will be working. So similarly, so this acronym can be used in the case of NumPy also. You can use any name here. So you may write import NumPy. You can write as N. Okay. But the most used acronym is NP. So we use NP. Okay. So you may write any name here. Okay. You may write NP or N or NP1 or NP2, anything. Okay. Okay. Now, a few things. If you want to check the version which you are using here, so you may simply go ahead and write np._version . It will give you the current version of your NumPy which you are using or installed on your system. Okay, it is this. And also there are a lot of methods available on NumPy module. So if you want to check all those methods, then probably you can go ahead and you can type here np dot tab, np dot and tab. Okay, it will give you a huge list of methods available in NumPy. Obviously, we are not here to discuss all these methods. Rather, we will be discussing few important methods which will be useful for us. And also the method which we'll be using, that also you'll be using in your day-to-day life. If you feel that some method which I don't know, you can go ahead and check what all methods are there with the dir of np. It will list you all the list of, it will give you a list of all the methods available in NumPy, and using that particular method name or function name, you can Google it out what exactly its role is, and then you can use that. Okay, fine. So now the next part is, let's say we'll see how we can create an array. So first I need to show you that how we can create an array using array module. There is a built-in array module in Python, how you can create. So you can simply write import array, and then you need to create one list. So see, whatever arrays we will be creating, we will be using either we'll be taking the help of list or range, or you can say a dictionary, okay, for creating the arrays. So as of now, I will just create a list of 10 values using range function, and then I will be passing that list to the array function in the array module. Okay, before that I need to specify the data type. So for example, I will be writing lst is equal to list of range of 10. Okay, now I need to create the array, so I write array is equal to array module. Inside array module we have array function, and inside array function, if you want to create an array, the first argument you need to mention here is what kind of data you are going to take. So here you are going to take integer type of data, so you will mention I, and then the second argument will be the LST from which you want to create an array. So this will create an array for you. Array. If you will run this, it is giving you array type. Okay, clear? So the value here are the integer type, and all these values are integer values. Okay, so this is the way you can create array using array module. Okay, you can create array using array module. So as we have said that there is a built-in array module, why we are not using this? So array module in Python provides you the efficient storage of the arrays, but NumPy, along with the efficient storage, it also provides the efficient operations. Okay, efficient operations on the array. That's why we moved to NumPy. So let's say if I want to do a few operations on this array, probably it may not be, it may be taking extra amount of time. Internally, some extra amount of time it might be taking. So we are not going to use this array module in Python. We are going to use NumPy. So for that, now I will import NumPy as np, and then I will be seeing that how I can create the array using NumPy module. So first of all, if you want to create an array, so the you can write here array is equal to np dot array, and inside this you can pass a list. For example, I may pass this list. Okay, and if I will write array, it will be creating an array. Okay, you can either write array or you may print it also. So once you'll be printing it, so you will see the difference between this. If you will just write ARR here, so it gives you that it is an array type. But if you will print it here, and one more difference, the elements are separated by comma. But if you will print using print statement this array, so that array removes that it is an array type, but internally it is an array type. Don't consider that, don't think that it is not an array type. Still it is an array type, and the values are normally separated by a space. Okay, so it is just the representation. When you use print function, it prints in this format. When you just write ARR, it gives you with array written in front. Okay, so it's just the way of representing or writing the value. Okay, now let's say in Python, the values will be, as we say, array is a collection of homogeneous data, right? Array is a collection of homogeneous data. Okay. Now let's say if I am saying array is equal to np dot array, and inside this I'm going to take 4 values, and third value I'm taking as float value. Then if I will print array now, so you'll see that all values are upcasted to float. Okay, float value. Fine. So if upcasting means, so upcasting, let's say if from integer the values will be upcasted to float value. From float the value will be upcasted to string value. Okay, so this is the basically the hierarchy. So if you will have at least one float value in your arrays and rest all are integers, so every value will be upcasted to float value. And if you have at least one value in the string, rest all are int and float, so everything will be upcasted to string data, or we say object type in array. Okay, fine. So upcasting, it doesn't allow downcasting. It will always upcast the values. So if you are adding one value, which is, let's say if you have a collection of integer value, but only one value you have entered, that is float value, so everything will be converted into float type. All the data will be converted into float type. Or if you enter string type, so everything will be converted into string type. Okay, fine. Okay. Okay. Now, let's say if you want to explicitly define the data type of an array, like what kind of data you are going to have in array. So you may write array1 is equal to np dot array, and inside this you may pass 1, 10, 20, 30. Okay. And here you may mention d type is equal to float 32. Okay, now you may print array1. So once you will run this, you will see that everything is converted into float type. Okay, so here you have mentioned that the data type explicitly should be float 32 type. Okay, now what this float 32, float 64, int 8, int 16, int 32, int 64, all this we are going to discuss in the data type, and give you an idea about that. But as of now, you can say that if you want to explicitly define if you want to explicitly define the data type of an array, that what kind of data you are going to have in an array, so you can go ahead and specify the data type of that array using the type attribute of the array function inside the numpy. Okay, d type is one attribute. Okay, now what all attributes we have of an array, so those all attributes will be learning in some time, but d type is one of the attribute where you can specify that what kind of data you want to store in the array. Okay.
Abhishek, one question. Hello.
Yes, please.
So, yeah, cell number 13. Can you just scroll up, please? Yeah. So here, all the integer values are converted into float. So the type of array will be like what? It will be like array or like object, because I did the same thing. It is giving class numpy dot nd array.
See, if you will check here type of array, so it is giving numpy.nd array, because numpy is what? Numpy is mainly taken into the consideration for defining the multi-dimensional array. Let's say if you will try to define the multi-dimensional array using this module, array module of array function of array module, you will not be able to do that. Okay, you cannot define the multi-dimensional array here. So that's why we came up with this numpy array. Okay, so numpy array allows you to define the multi-dimensional array. So if you have created one dimensional array also, it will show you that the type of that is nd array. Okay, now when I'm talking about d type is the data type of the element inside the array, not the type of this array. Type of this whole arr variable is nd array only, or you can say it is array type only. Forget about this nd array. Nd means multi-dimensional array. Okay, so forget about nd, array type. It is an array type. Okay.
Yeah, got it. Yeah, thank you.
When I'm saying d type is equal to float 32, so d type is associated with the value inside the array. Okay, that value will be converted into float type. Okay, type array will be the type of array, not type of elements. Yes, correct, Shabi.
Yeah, Abhishek, here this direction is into float and float to string, so it will not reverse, right?
No, like if you have string and if you will pass one int object, it will not be downcasted. It will always be upcasted. Okay.
Okay.
Abhishek, in cell number 7, can you scroll up? So here, what is the use of I? Array dot array.
it is saying that I basically, okay, so there is a table.
Looks like that is a kind of string. So because arrays will store only the homogeneous data.
1 minute.
I'm a bit confused.
So see, this is, if you want to have your this is the array module. In array module you have this I. Okay, when you write I means you can store only integer value inside your array. If you write B, unsigned character, if you write U, Unicode character, if you write H, signed short value, if you write F, then you can store only float value and so on.
Okay, got it. Thank you.
So I is basically representing okay. I is basically representing this data type of the element which you are going to have inside this array. Okay. Yes, you're asking some second question. What is that?
That's all.
That's fine, right?
Yes, yes.
Abhishek, one more question. Can we have one sample array where we will have heterogeneous data? Can we do that?
No, you cannot have an array with the heterogeneous data. That becomes a list. Okay, and if you will talk about, see, so if I'm trying to create an array with the heterogeneous data, internally it is upcasting to the higher value or higher data type.
Yeah, I tried, but again, the type, when I print the type, it is again giving the same numpy.nd array. I thought it will give it as object.
No, 1 minute. See, if you are trying to get the data type of the element, you have to type ar.dtype. Okay. If you see, it will give you float 64. Okay. So this float 64 gives you the data type of the, so to get the data type of the internal element, you have to write d type. Okay. If you are writing type of array, it will always give you nd array. Because
Okay,
type of the
yeah,
array.
got it.
Okay.
Yeah, got it.
Abhishek, I have one question. In cell 14, we are explicitly mentioning d type as float 32. So instead of that, can't we write directly float integer?
You may
Why
write,
we are mentioning 32?
yeah, you are
64?
saying you want to write like this float.
Yes, yes.
You can write it like this float, but internally you need to check by default in which format it will be stored. So then it will be storing. Then it will be storing in the float 64. Okay. So float 32 and float 64 are the two data type, like, so smaller value you can, like, there is a single precision, double precision values of float. So we'll be learning about that in the array data type.
Okay.
In the upcoming sessions. So why we are using float 32, why we are using float 64. So we'll be learning about that, but just give me some time. We'll be discussing it there. Okay. So you may write only float. By default, it will be taking either float 32 or float 64 based on the operating system you're using. Okay. If you have 64-bit operating system, it will be storing it in the float 64. Okay.
Okay. By default, it will take.
Yeah.
Okay.
Okay. Only if you write float. So if you want to store in a specific type, then write it float 32. If you feel that your float values are too smaller, then write float 32. Okay. If you feel that it is quite bigger, then write float 64, no problem. Okay.
Okay. And in one more, in cell number 7, you said I is used for the integer. And the type would be as if we check the output, if we check the type, then it would be array or integer.
Here, if you will check the type of this, again, it will be an array. Okay.
Array only.
Here.
Yeah, because we are using array module, is it?
So if you will check, it is an array. Okay. If you want, see, this I is for the element of the array. Okay.
Element. Okay. Yeah. Thank you.
Okay. Now,
Abhishek, I have a question regarding that upcasting. You have written the casting sequence as integer, float, and then a string. So if one element is a string, all other will get converted into a string,
Yeah,
correct?
let's say if I will keep this in the quotation, okay, everything will be an object type, okay.
Correct. So when you write these three, does that mean it will only take three types of data like integer, float, and string?
Sorry?
You have written a sequence. So does that mean that NP array will only take three data types?
No. See, basically there is nothing called string. There is something called object, okay. Correct. So let's say in this object now everything will come, string, list, and other values, other types will also come. Okay, so obviously, let's say if you will try to keep a list, it cannot convert this whole thing into a list or array type. Okay, so that we will see later. But as of now, why I have written this thing? So we will be learning about the other upcasting hierarchy in the coming classes. But these all are the three very known types we know. So int, float, and string. So if you will write anything into the float, then everything, if you have written everything in int, so that int will also get converted into float. And if you're writing it in the string format, so int and float will also get converted into the string format, like you can see here.
Thank you. Got it.
Rest all we will discuss. Okay.
Thank you.
Okay. Now we are going to explicitly define the. We have seen that how we can explicitly define the data type and resulting array using D type attribute. Now let's see how we can create a multi-dimensional array. So for creating a multi-dimensional array, we know that how you can create a multi-dimensional list using loop comprehension. We already have seen. So let's say, for example, AR is equal to np dot array, and inside this you may pass a multi-dimensional list. For example, I will write I into j for j in range 4 for I in range 4. So there is no error. Print. Now, if you'll see, so let's say if I will just run this. Yeah. So you can see that structure wise also it is not it is not showing in the multi-dimensional array type, it is showing in a single list type. Okay, so representation wise also it is not efficient. You can say if you are having multi-dimensional list, you have to consider, okay, so you have to count with this two list or two, you can say what do you say, two opening brackets in the beginning, so you can say okay, it is two dimensional. Here also you can interpret with the same thing, but one more thing is that there are rows and columns. With this you can easily identify that is a two-dimensional arrays. Okay, now we'll be looking at the three-dimensional arrays also, how you can create. But if you want to create an array, two-dimensional array, so you can pass a two-dimensional list that will be converted into a two-dimensional array. Then that is how it will be represented. Here also, if you want to specify the data type, you may simply go ahead and write d type is equal to float 32 or anything. So everything will be converted into float type. Okay, fine. The next part is routines in NumPy. So what is routines in NumPy is, routines is basically to create the array from scratch. Okay, for example, I want to have an array or create an array where all the elements are initialized with 0. Okay, so what I need to do, one option I have is I can create a list where all the elements will be 0. Okay, so and then I can pass that to array function. So doing that again, that is an extra step, but for that we have a built-in function. Okay, so you can do that using that function. Similarly, if you want to create an array where you want to have all the elements, all the 10 elements should be 1. Okay, similarly, if you want to create, so that is one dimensional array. If you want to create a multi-dimensional array, let's say two-dimensional array, where every element will be having 1. So how you can do that? Let's see all these things, how you can create. So these all are called the routines. Okay, why do we need routines? So if you want to create an array for some fast calculation, you don't have to go and write the for loop and everything. We will see that how for loop is affecting your program. For loop takes longer time than creating the array using function. Okay, let's say if I will say that to create this array, you can say that I will take the help of loop. I can simply write this. Yes, you can write this, but this is taking more time than creating the array in this manner. So obviously you can replace this part. Let's say if you just want to create an array, creating an array of 10 values where everything or every element is 0. Okay, so if you want to do that, then what you can do, you can simply go ahead and write print np dot zeros. Zeros is a function, or we say this zeros is a routine also, which creates a list, which creates an array of the specified dimension, like of a specified number of element, and you can also specify the data type for that. For example, I want zeros means it will create an array where every value will be 0. Now, how many elements will you want? So I want only 10 elements. I want only one dimensional array. So I will write 10, comma. I want data type to be, let's say, is equal to, I will write int 32. Okay, you can specify int 32 also. Now if you will run this, you will see that one array is created with where you have 10 elements and all 10 elements are initialized with 0. If you will check the data type for this, so you can just write d type and it will give you that it is int 32. You can change it to float 32, float 64 or anything. Okay, fine. Clear, everyone?
Yes, Abhishek.
Okay. Now, similarly, you can create an array of 10 values where every element will be 1. Okay. So for that, we have a function called np.ones. This all we are creating one single dimensional array, np.ones. And if you want to create this, so just remove this, not required. Run this, one array is created where 10 elements are there and all the elements are having only 1. Okay, so this is using ones. Now, let's say if you want to create this ones routine, but multi-dimensional array, for example, 4 cross 5. Okay, so 4 rows and 5 columns. Okay, so one thing you need to keep in mind, let's say if I will mention anything in the bracket. Okay, so the first value will always represent to row and second value will always represent to column. Okay, so if I'm using any such notation, so remember one thing, that the first value is representing to row and second value is representing to column. Okay, now, so let's say if I want to create a 4 cross 5 multi-dimensional array where all values are set to 1. Okay, so I will write here creating a multi-dimensional array of 4 cross 5 size and 1. Then what we can do? So we can simply write print np.array, and here we may write 3, 5. Means it is first is row and 5 is column. So 4 is row and 5 is column. 4 cross 5 we want, and then it will be float. It depends. If you want a float value, you can specify that it is a float. Okay. Here it is int. I have specified it as int value. Okay. So now I will specify the d type. So if I want, I can write d type of, as I can write float 32. Now if I run this, so sorry, np.ones. Okay, I've got the array 4 cross 5 array, means 4 rows you can see, 5 columns you can see. So 4 cross 5 row where the data type is specified as float type. Okay, and all the values are initialized with 1. Okay, so these all are used in doing the fast calculation. You don't have to go and write the loops and all those things for that. You can simply use these routines and it will be easier to create and faster to create. Okay, fine. So this is once. Now we have one more function np.full, which creates, so let's see what it does. So what we want to do, creating an array of 4 cross 5 where all elements are set to 3.14 by default. So you can simply write print np dot full. By default, all the values are set to 3.14. So you will write here inside full function, what is the dimension? First, I will write the dimension. I will write 4, 5 row and column, comma, the values should be filled by 3.14. Okay. So let's say for zeros, you have zeros, for ones, you have ones, but for twos, threes, nines, tens, and all. So how you can do? You can use np dot full. Okay. Now, if you will run this, you will see it is created like this. Okay. So now it has created 4 cross 5 array, and all the values, all the elements are filled with 3.14. So full is a function to create an array in this manner. Okay.
Can we have alternate 1010?
10
like unit matrix? How we have?
Which matrix?
Unit matrix 1001.
Unit matrix means you will be having alternate element as 1010, or identity
Yes.
matrix you want to say, like here diagonally you will have one.
You can, okay, identity matrix.
Identity matrix, yes, we have for that np.I function. Okay. Now, so next is using arange function. Also, you can create an array. Arange function is similar to the range function in Python. If you remember range, so range function creates a sequence of, let's say if I will write range 1, 20 or 21. So it will create a sequence of 20 values starting from 1 to 21. So if you want to get values, then you can just type it into the list function. Okay, it will create these values. But how you can create? So is there any facility available in NumPy also? Yes. So for that we have arange function. Okay. Now this arange function, let's say if you want to create a one-dimensional array with odd elements between 1 and 20, so you can use this arange function. Okay. So I'm going to create a new one-dimensional array with all the odd elements. So I'll write np.arange, okay, and 1, 21, 2. So all the odd elements will be taken in this case. Okay. Fine. Okay. Now, creating a one-dimensional array where we have 4 equally spaced value. Okay. For example, let's say between a specified range. For example, that function we have is linspace function. Okay. Now, what this linspace function does, it creates an array with equally spaced value in a definite range.
Abhishek, in here, so in the above function, what is the default D type? If you don't
default, okay, so let's say if you will not write this, it will take 0. Sorry, remove this.
No, not here, the above functions.
This one?
No, above.
This one?
No. Can you scroll up more? Yeah.
Okay.
So if I don't specify D type here, what's the default one is going to be?
Default, it will be taking integer.
Okay.
Okay.
Okay, got it. Thank you.
It is still taking 4, 5. So let me write it here. No, it is taking it as a float.
Default is float, you mean to say?
Yes, float. Float, you can check the D type of this. So what is float, 32 or 64? Type it is 64. Okay. Okay, now linspace. So linspace is, let's say if I want to create a one-dimensional array where we have 4 equally spaced values, then what we can do in a specified range. So we will write print np.linspace, and I'll specify the range between 0 and 1, and we want to have the 4 equally spaced value. sorry, 5 is equally spaced values. So 1, 2, 3, 4, 5. We have written 5 here. Okay. So you will see between 0 and 1, this has been divided into 5 equally spaced. So 0, then 0.25, 0.5, 0.75, and 1. I can write it as 10 also. So it will create 10 equally spaced value. I can write it to 9 also. It will create 9 equally spaced values. Okay. So whatever you will specify here, it will create that many, I will write 9 here. So that many equally spaced value inside an array. So linspace is used for that. You can specify the range. So first value will be the from where you want to start till where you want to get. And in that range, what is the equally amount of values you want to be distributed. So you can specify that equally amount of values. Okay. If you want to write just one, you may write one and it will create only one value. Okay.
Abhishek, this A range and linspace, are these possible in multi-dimensional?
Yes, yes, it is possible in multi-dimensional array.
Can you show one example?
I'll show you.
In one. Okay.
So now let's say now I want to create a 3x3 array with uniformly distributed random values. Okay, some random values I want. So for that we have random module in Numpy. So using that we can create. Now let's say if I will write it here, 3x3 array of uniformly distributed random values, then I can simply go ahead and write np.random.
Why we will call it as a routines? Is there any
routines? Because routines means what? Tell me, like, when you follow a routine, you do a task on a regular basis, right?
Yes.
Correct. So we follow that. We don't have to think about it that, okay, so if I have to get up in the morning, what I need to do. So that is the routine, right? So the same way, if you want to create a task or if you want to create an array of these types, then you can simply go ahead and use them. So they are used for a fixed purpose. That's why we say they are routines.
Kind of built-ins.
Kind of?
Built-ins.
Yeah, built-ins, yes, built-ins.
Okay.
Now, if you'll see here, so it has created an array, 3x3 array of random values. Okay, it will take some random values. Let's say if I'll run it next time, or if you will run it, it may give you some different values. Okay, it is not like it will give you always a fixed set of values. So it will always give you a random value. Okay, now one more thing you need to understand, that if you want to, let's say, fix it, then you can simply go ahead and write np.seed of 0. Okay, now np.seed, let me check where it is. Random.seed. Okay, so now if I will run this, it doesn't matter how many times you are going to run this, so it will always create the value. So seed means this seed function is used for reproducibility. Okay, means if you want to reproduce the values every time, the same value which you are working, then you go ahead and take the help of seed function. Okay, fine. So if you will write this np.random.seed, now if you will use the random function to generate the random values, then it will generate the fixed set of values every time. Okay, it may be useful, let's say if you are doing some testing, okay, and you have done a testing on this data. Let's say, forget this, if you have done the testing on this data, okay, now if you will give this code to someone else, for him it will generate a different data set. So in that case, probably the result he or she is expecting, he or she might not get. So instead of that, what you will do, if you will do this seed, so it will generate the fixed set of data every time he or she will run the code. Okay, so you'll see whenever I'm writing seed 0, it will generate only this set of values only.
Okay, only 0 can be given?
No, you can give anything. So different number will generate a different set of values.
Okay.
Okay, you can give anything of 0, 42, 5, 50, different number will generate a different set of values.
That 5 seed 5 represents the 5 times of repetition values, or 5 random values?
No, not 5. It is 5 is just a number which shows that whenever user will write 5, these all values will be created. Whenever user will write 0, these all set of values will be created.
Oh, okay. Fixing the values to a number.
Yeah.
Like,
yes.
Okay. And I have another note like np.random. Okay. Then why you are calling a random again for 3x3?
Random is a module in NumPy, and random is a function in this random module.
So we have to get a value between 0 to 1. We have to use random again, like random dot
random function. This is a random function. This is the random module, and NumPy is kind of package which you have downloaded.
No, what I'm asking is, it is only for the values between 0 and 1.
Which one? This no. It's yes, sorry, yes, between 0 and 1.
Yeah, that random model.
Yeah.
Okay.
How can you specify the different range? Let's say 1 to 10.
1 to so if you want to generate these values from 1 to 10.
Yes. Randomly, yes.
Yes, random values. So for that we have different functions. In random module itself, we have a different function. We'll look into it. Probably random module we have not covered in Python. So there are different functions. We'll be learning about that. But as of now, if you want to do that, so you have this different arrange or linspace. Using that, you can do that. Okay. For example, if you will write 10 here, okay, 10, 9. Now, if you will run this, so 9 different values will be created. Okay, now it is not random, it is equally spaced, but in using random module, yes, someone has given this random.randint. Let me check np.random random.randint. Randint takes at least one positional argument. Let's say if I say 3.5. 1, 2, 3, 4. So it generates a random value. Okay, so not one. So let me check the function to create an array. Okay, I will tell you. Let me see if I have different function. Random.randint, correct, this function. 1 minute.
Will work same as range.
Maybe you should give some matrix.
Random.randint 0, 10, 3,
size. You should provide size equals to 3, 3.
Hello. 3, 3 is the, this is the
of matrix.
Yes, dimension. Okay. And 0, 10 if you are passing, so this is in which range you want to specify the value. Okay. So basically we could have done this. So yes, low, high, size, and d type. So basically there are the 4 attributes in randint you can pass. The first one, from what is the low value, from where you want to start taking the values till where you want to go, and then size I have mentioned 3, 3. I've not mentioned d type, but if you'll see, so low I have mentioned 0 and 10. So between 0 and 10, it will take the random values and then it will create an array out of it. Okay, so it has taken some random values 0, 3, 3, 7, 9, 3, 5, 2, 4 and all. So this is the randint function which generates the random value. Okay, we'll see the values we same for. Yes, it will be same from computer to computer, Sandeep. Start, stop, and step need to be mentioned. Where start, stop, and step? In arrange, no, it is optional. Sampath, it is optional. Random function returns values between 0 and 1 only. Random function. See, random.random function, yes, this will return only 0 and 1. And if you want to have the random value, then you can go for randint. Okay. Now, there is one more function.
Abhishek, one question regarding seed. It said we can give any value for seed, right? But how to identify what is the correct seed for that particular random?
Seed. No, not correct. Actually, basically that seeding is used for the reproduction, okay, of random values. Now when you don't write this seed, so if you will run this random, it will generate some random value. You don't know that which value will be created. Okay, but yes, if you give this seed 0, then you know one thing, that it will always be created from this value.
Yeah, that I got. Yeah,
And
thanks.
it will be fixed. This will be fixed. Okay. Now, if so, you are doing it for testing purpose. So if you are doing it for with 42, then always it will be created with 42. So the other programmer which who is working on this, so he will be using 42 only, not the other number. Otherwise, probably the data discrepancy will happen. Okay.
Yes, understood.
Now, the next part is creating a 3x3 array of normally distributed random values. So we are going to create normally distributed random values. So normal distribution is again, so a bell-shaped curve basically it creates. So if I will run this, so the code for that is np.random.normal. And if I want to generate between 0 and 1, and then I can write this. Okay. So this will generate a normally distributed value of array. Okay, fine. Clear? So it is starting from minus 0.5 to minus 0. It is going till minus 0.4. And then in between, you will see that there is a peak 2.16. Okay, fine. Next.
So if you want to have negative values in the array, we should use normal.
We should use?
We can use normal function.
No, not only negative values. Sometimes it may generate the positive values also. It is the normally distributed value. Basically, normally distributed value means what? So what is the normal distribution curve you have seen?
It will have both positive and negative values.
Yes, it will have the combination of positive and negative value. And it is in such a way that, let's say, if you will combine all the values, probably somewhere you will get the 0. Okay. Means combination of all the points, if you will do, you will get the 0.
Yeah.
Okay. Yes, it relates to that, Rohit. Normal distribution. That is the.
What if we want to have negative values in the matrix? I mean, in the array without using the normal function. Is there any other function that?
You can specify the range. We have seen the number of functions here. You can specify the range. Okay, a range is there or linspace is there. You can specify the range.
Okay, we can use -1 instead of 0 also, right?
Yeah, you can specify the range here.
Okay.
Okay. Yes. Any other question?
Is that normal distribution is always a standard normal with both side equal always?
Yeah, both side equal means it will always follow this curve. Somewhere there will be like, probably let's say this part will be bit, extended, or this part will be a bit lower. But generally it is distributed in this manner only. Okay, so the values will be distributed in this manner. Okay, so starting from here till here, if you will observe, so the values are distributed. If you will plot it in using matplotlib, so it will show you the normal distribution. Okay.
Okay, you have mentioned in the comment saying that with the standard deviation as 1. So
yes.
Here 0,1 is indicating that one?
SD, sorry, what?
In the comment, you have given mean as 0 and SD
No.
as 1.
I have specified this as the argument. Okay, so I can mention here. Let me mention here too. So it is taking any argument. So this SD is basically 1, mean is 0. Okay, so if you find the mean of these values, it will always be 0, whereas standard deviation will always be 1. Okay. Now this argument you can mention anything. So this is the start and stop. Basically, you can see here. This is the location and scale. Basically, it represents.
Okay. So the normal always gives the mean as 0 and the SD as 1.
Yes.
If we have. Okay.
Yeah. Okay.
So in this normal distribution, we can able to see the skewness also.
Normal, we can able to see.
Skewness.
Sorry, not
Skew.
clear. No, I don't have any idea about that.
Okay, so usually in the normal bell curve, we can able to see like, positive skew and negative skew.
No idea about that.
Okay.
Sorry.
Abhishek, one question. So when we try to generate this normally distributed random values, so should it always start with 0 and then some other number? It can be anything, right?
You can just specify 1. So let's see if it's starting from 1. Okay. Fine. Now, someone asked me for identity matrix. So for that, we have I function. Okay, creating a 3x3 identity matrix. So we can simply go ahead and write array is equal to np.I, and we can specify 3 here. Non-reduced skewness is minimum. Need to check, Swati. Probably I'm not from that particular. I have not enough.
I'm answering that question, what she said. So in normal distribution, skewness won't be there, only if it is a normal distribution. Otherwise, there will be a skewness in the curve. Just answering.
Really, not much idea about statistics or this concept. So then I need to read about it. Okay. Fine. So let's run this np.I. I'm going to get identity matrix array. And you have, so in identity matrix, we know that we will have, so this is a 3x3 matrix. Whatever you will mention, 3 or 4, it will always create 4x4 or 3x4, 4x4 or 3x3 or 2x2. Okay. So mentioning one values, actually it takes rows and column as similar, and this you will be having always this one in the diagonal form. Okay, so let's say if you're writing 5, then it will create a 5x5 matrix, and then all the ones will be in the diagonal position from left to right. Okay, so this is how you can create an identity matrix. Now, so we are done with this. Next, we will start with the NumPy in standard data type. This is quite a big topic. I'll start it tomorrow. Okay. Data types and then basics of NumPy arrays. So everyone is comfortable with 7:30?
Yes, yes, sir.
Okay. Yes, fine. Fine then. So we'll make it at 7:30 only. From tomorrow, I'll not tomorrow. From day after tomorrow, we'll try to make it till at least 9:15 or 9:30. Okay.
Okay.
Abhishek, I have one doubt in cell number 10. As you have changed these parameters 1 and 2.
Cell number 10.
No, not above. Can you scroll down?
This one?
No, going up. I think it's not 10. I'm sorry. Yeah, it's 101. Sorry.
Yes,
so 1 and 2, you have changed this. So we are getting output as 6 also, 6.55, 3.38.
So that's what. So I probably I need to check what exactly. So read something about normal distribution. Probably you will get an idea. So basically, a normally distributed array, if you want to create with mean 0 and ST1, then it will create an array like this. Okay. Now, what all values it will have? So probably I will explain it in the next class. What exactly a normal distribution going to do? I'll explain it in the next class. Okay.
Okay. No problem.
Can you share this document in?
Yeah, I will upload it in. Let me share it here. A minute. You can download it right now. I'm sharing it in this chat box. Okay.
So class will be only on the alternate days?
Yeah, it will be only on the alternate days. I have given it in this chat box. You can download it right now and keep it yourself. I need to check whether classroom will be created or some other way to communicate with with you guys for these classes, how it will be done. So accordingly, it will be uploaded there. But as of now, I have uploaded it here in the chat. You can download this, okay, right now. And next part is classes we will be having on Monday, Wednesday, and Thursday. Okay. So day after tomorrow, we are going to have the next class. Rohit, do you have any question? You raised the hand.
Yeah, Abhishek, can you just summarize the overall difference between the array module and the NP, I mean, inside the NumPy array mod, I mean, just to summarize, what's the basic difference between those two?
One of the most important difference you can understand here is that using array module, you cannot create multidimensional array. You cannot work with multidimensional array. And nowadays, most of the data which are coming are into the multidimensional array. That the kind of image processing data, if you're working upon, then that is the multidimensional array, two-dimensional array, right? You cannot represent it using array module. And again, if you will go by, array module provide you the efficient storage of the array, but it doesn't provide you the efficient manipulation of that array in the array module. So we came up in NumPy. NumPy provides you the efficient storage along with the efficient manipulation or efficient operations, and also it handles the multidimensional arrays also. Okay, and one more important thing is when the data grows, or if you have a huge amount of data, probably your Python array module will not be able to handle that, whereas NumPy is capable of handling the huge amount of data as well.
Okay, yeah, thank you, got it.
Kishlai, there is no difference between I and identity matrix. I is an acronym for identity. So instead of writing identity, the developer has written EYEI. I is just an acronym for identity matrix.
So Abhishek, in this class, the NumPy is completed.
No, not NumPy. But NumPy is we are going to have at least 1 or 1.5 week of class.
Okay, for next 2 weeks, we'll have the classes like this.
Yeah, I think this week completely, Wednesday and then Friday, and then next week also Monday and Wednesday we will be having the class on NumPy.
Okay.
Okay.
Yeah.
May I ask you, Abhishek, that how many total classes will be there for these topics?
Probably, as I said, around 1 month of classes will be there for this whole data science module.
Okay, sure.
Okay. Will these 3 days class and weekdays be repeated in the weekend classes? No, see, these all are the extra classes. It is not related to weekdays or weekend classes. Weekdays and weekend classes are completely different. These all are the extra classes which we are providing, Arvind. Yes, the other trainer who is taking the classes for this Numpy and Panda, probably these all things they will be repeating there, or you might have already read them. Most of the candidates might have read it or have attended the classes for that, or you are going to attend. Okay, so I think one class is done. So these all things you might have seen there. These all functions. Where you are aware of this.
Abhishek, this is Bharatwaj here. Like this video will be uploaded today, or will it be uploaded again tomorrow?
It will be uploaded by tomorrow. So evening classes, whatever we take, those will be uploaded by next day.
Okay.
That will be uploaded in the YouTube playlist, and that YouTube playlist will be shared with you, Rohit, with everyone. You will get the class recording there. Okay, probably. And Shankar, so we have made it from 7:30. Everyone is comfortable with 7:30. So let's make it from 7:30 when I also have to go to bed early. So that will be good for me. And even I'm not free after 9 or 9:15. So I have to take the call from office. So that's why even I was also comfortable with this timing. Shankar, okay.
Okay,
someone please share the today's file in WhatsApp as I am accessing. I will share it in WhatsApp also. Let me open the WhatsApp. WhatsApp where I should share. So there is not a single group. I cannot share in every group. I don't remember even those groups. So you guys can share, like those who have downloaded it from here, you guys can share. And probably I will check with the Learnbay, and then I will ask them to create a Google Classroom for this data science class. And there we will upload all these files and recordings. Okay. You'll get all these things in a single place. Fine. Okay. Yeah. Thanks. Thank you for joining. Good night.
Thanks. Abhishek. Good night.
Thank you, Abhishek.
Thank you, Abhishek.
Bye.
Thank you.
Thanks, bye.
Bye.